How to fix Valorant VAN9003 error on Windows 11. Welcome back to Compatibility. The Valorant VAN9003 error has become a massive roadblock for Windows 11 users, preventing the game from launching due to strict Riot Vanguard compliance checks. During our intensive hardware diagnostics, the Compatibility team discovered that this error is intrinsically tied to how your motherboard's firmware handles cryptographic security and boot validation. Vanguard strictly mandates a fully functional Unified Extensible Firmware Interface environment paired with active trusted platform module architecture. Fix Valorant VAN9003 Secure Boot TPM BIOS UEFI JPG. Our engineering team tested multiple motherboards and operating system configurations to pinpoint the exact chain of failures causing this boot loop and access denial. We found that simply toggling a switch in the settings is rarely enough, as conflicting legacy boot sectors and outdated microcode often block the security handshake. In this comprehensive technical guide, Compatibility is exclusively sharing the definitive, step-by-step resolution path that our technicians verified to completely eliminate the VAN9003 kernel block. Step 1. Diagnosing the TPM2 0 status via Management Console. Compatibility's initial analysis revealed that checking your baseline cryptographic readiness is the mandatory first step. Press the Windows key and R simultaneously to open the Run dialog box, then type TPM MSC and press Enter. Verify that the status explicitly states the module is ready for use, confirming your hardware is communicating with the operating system. Step 2. Analyzing the secure boot state in System Information. Even if the module is active, Windows might not be enforcing the boot signatures required by Vanguard. Open the Run dialog again, type msinfo32, and locate the secure boot state line in the right pane. If our system analysis shows this as off or unsupported, you have a firmware-level configuration mismatch that must be resolved. Step 3. Accessing the advanced firmware interface. To modify these locked parameters, you must bypass the fast startup cache and enter the motherboard configuration natively. Hold the Shift key while clicking Restart in the Windows Power menu to access the advanced startup environment. From there, navigate through Troubleshoot and Advanced Options to select UEFI firmware settings. Step 4. Disabling the Compatibility Support module. During our laboratory testing, we identified the Compatibility Support module as the primary conflict generator for Vanguard. Locate the Boot tab in your firmware interface and completely disable this module to prevent the system from attempting legacy handshakes. This forces the motherboard into a pure, modern boot architecture required by modern anti-cheat engines. Step 5. Activating the Secure Boot Protocol. With legacy support disabled, navigate to the Security tab to manage your boot validation parameters. Toggle the Secure Boot State to Enabled, which allows the motherboard to verify the digital signature of the operating system loader. Our testing showed that saving at this exact moment often triggers a reboot loop, which leads us to the next critical fix. Step 6. Bypassing the firmware save loop. If your system kicks you back to the firmware interface after enabling the security protocol, the factory keys are out of sync with the operating system. To resolve this synchronization failure, Compatibility recommends changing the secure boot mode from standard to custom. This unlocks the advanced key management submenus necessary for rebuilding the cryptographic database. Step 7. Executing a factory key restoration. Inside the custom mode settings, select the option to restore factory keys or install default secure boot keys. Accept the prompt to overwrite the current variables, which flushes the corrupted platform key data that was causing the infinite restart loop. After the keys are installed, switch the mode back to standard to lock the configuration. Step 8. Flashing the motherboard microcode. Our extensive testing confirmed that older firmware versions on specific motherboards absolutely refuse to save the restored keys permanently. You must download the latest non-beta firmware update from your manufacturer's official support page onto a formatted flash drive. Use the built-in flashing utility within your interface to rewrite the system management memory. Step 9. Reactivating processor-level cryptography. Flashing the motherboard completely resets all custom variables, meaning you must rebuild your security profile from scratch. Navigate to your CPU configuration settings and locate AMD FTPM or Intel PTT, depending on your processor architecture. Enable this firmware-based cryptography so Windows 11 can register the hardware security layer once again. Step 10. Verifying the disk partition scheme. If your primary storage drive is utilizing a legacy format, forcing modern boot protocols will immediately crash the operating system launch. Right-click the Start button to open Disk Management, right-click your primary disk, and select Properties to view the Volumes tab. Our technical team requires this partition style to be GUID Partition Table for Vanguard to function correctly. Step 11. Converting the drive architecture via command prompt. If your drive is mapped as a master boot record, you must convert it without destroying your localized data. Open an elevated command prompt and execute the specific mbr2 gpt tool command to rewrite the boot sectors dynamically. This advanced procedure seamlessly modernizes the file system mapping so the security checks can pass. Step 12. Creating a modern installation media. If the conversion fails and your drive is heavily corrupted, Tenabalta highly recommends preparing a clean installation environment. Download the Rufus utility and load a fresh Windows 11 image, ensuring you explicitly select the non-legacy target system option. This guarantees the newly written boot sectors will natively support the required cryptographic handshakes. Step 13. Enabling Windows Core isolation. Vanguard deeply integrates with the Windows kernel, and missing security virtualization will trigger immediate access denial. Search for Windows Security in your taskbar, open the Device Security menu, and access the Core isolation details. Ensure that memory integrity is toggled on to prevent malicious code from injecting into high-security processes. Step 14. Purging the corrupted anti-cheat installation. Once the hardware and operating system layers are perfectly aligned, the existing anti-cheat engine must be purged. Open your installed applications list and completely uninstall Riot Vanguard to remove the desinced registry keys. Our diagnostics prove that retaining old installation files will cause the software to ignore your newly configured firmware settings. Step 15. Erasing leftover encrypted directories. Even after a standard uninstallation, hidden kernel drivers often remain cached deep within your system drive. Navigate to your root program, files directory, and permanently delete the entire Vanguard folder to ensure no compromised data survives. Empty your recycling bin and reboot the system to finalize the complete removal of the application footprint. Step 16. Initializing a clean kernel deployment. Launch the Valorant client using elevated administrator privileges to force the game to download a pristine copy of the security engine. The software will detect the missing directory and rebuild the kernel drivers natively around your active cryptography modules. Allow the client to fully complete the installation process without interrupting the network stream. Step 17. Configuring the background service startup behavior. Occasionally, the newly installed engine fails to initialize dynamically with the operating system shell. Open the Windows Services Manager by executing Services, MSC in the Run dialog, and locate the background process named VGC. Right-click this item, open its properties, and forcefully set the startup type to Automatic. Step 18. Resetting the hardware state via CMOS. If you still experience a persistent VAN9003 block after following our core procedure, your motherboard might hold a stubborn static charge locking the memory. Power down your machine entirely, disconnect the power supply cable, and safely remove the circular battery from the motherboard for exactly 5 minutes. This physically drains the volatile memory and resets all hidden security parameters to their absolute factory defaults. Step 19. Updating the core chipset drivers. Our final hardware-level diagnostic revealed that outdated communication drivers can silently break the hardware security module transmission. Visit your processor manufacturer's official download portal to secure the absolute latest chipset installation package for your specific socket type. Executing this update repairs any broken communication bridges between the operating system kernel and your motherboard firmware. Step 20. Executing the final system initialization. With all firmware updated, variables reset, and the game files completely rebuilt, your machine is now fully compliant with Riot's strict parameters. Perform one final complete system restart to lock the newly generated security hashes securely into the motherboard memory. You will now be able to launch the game smoothly without encountering any compliance warnings. Don't forget to follow Tenabalta for more.